Welcome to the Unit 2 outline for polynomials. The first question on here is, can I factor? So for example, x squared minus 2x minus 15. So if we want to factor that, we can do the x method. We want two numbers that multiply to negative 15 and add to negative 2. So that would be negative 5 and 3. Negative 5 times 3 is negative 15, and those two add to negative 2. So I would write x minus 5 times x plus 3. We also looked at factoring the greatest common factor. So that means, what are all the terms divisible by? Or what do they all have in common? So for example, 2x squared minus 18. Both of these are divisible by 2. So I can divide them by 2 or factor out a 2, put it in the front, and this divided by 2 is just x squared, and this divided by 2 is negative 9. Then I can factor what's left here. So I can do the x again. They should multiply to negative 9, but add to 0 because there's nothing in between. The b value is 0. And that would be 3 and negative 3. So at the end, I have 2 times x plus 3 times x minus 3. And that would be completely factored. So make sure you look for greatest common factor first when you're factoring. The next part was operating. So that means adding, subtracting, multiplying, and dividing. When we add and subtract, we just look for combining like terms. Make sure they have the same variables and exponents. When we multiply, we distribute. So when we multiply, say it was x minus 5 times x plus 3. X times x times 3, negative 5 times x, negative 5 times 3. When we divide, that's where we used synthetic division or long division. And make sure you watch out for remainders. If you have a remainder, remember to write it at the end of your answer. So the next part is, how do I tell the difference between a factor and a zero, or also known as a root? So a factor is when you see something like we had up here. So for example, x plus 2. If that's the factor, to find the root or the zero, we set this equal to 0. And we solve, so take away 2 from both sides. And the root is x equals negative 2. So this is where it crosses the x-axis. So the factor just tells us that if we set it equal to 0, then we'll know what the actual x-intercept is, or the root. How do I actually find those zeros and factors of polynomials? We had a few ways that we did that. One way was from a table. So we looked and saw, where is the y0? And those gave us the roots. Another way was graphing. So you could even graph a function in your calculator and look at where it crosses the x-axis. And the last way was using division. We used synthetic. You can also use long division. And factoring. So this would happen when we are given a factor. That means we can divide by it and factor what is left. The next thing we did in polynomials was we looked at their graphs. We started by looking at their end behavior. So how do they act on the left and the right side, on their ends? So we had a little table for odd and even degrees and the coefficients. For even degree, remember that could be like x to the 4 or 2x squared, anything with an even exponent. So here, positive coefficient would mean that it's positive, positive 2, 1. In that case, both of the ends were going up. But when we switched it to negative x to the 4, or negative 2x squared, then all of a sudden they were flipped the opposite direction. For odd degree, that would be like x cubed or x to the 5. We found that when it was a positive, they were going down on the left and up on the right. But when we put a negative in front, for example, negative x cubed, now they switched directions. And the last part we did with the graph matching was the multiplicity of our zeros or our roots. And how does that look on a graph? So for example, maybe you see your equation says x plus 3 squared. The multiplicity is here. The multiplicity of this factor is 2, or the 0, and that means it has even multiplicity. So on the graph, it will actually bounce on that spot. So the factor is x plus 3, so the root is x equals negative 3. And let's do an odd one. So how about x minus 1 to the 3? So the multiplicity here is the exponent, which is odd. And since it's odd multiplicity, we know that instead of bouncing, now it actually crosses the x-axis. At this time, it would be x equals 1. Because the factor was x minus 1, so the 0 on the graph, it will be at x equals 1.